So, Assalamu alaikum and hello everyone. Thank you for joining us tonight. Tonight we are going to have a session on .NET and Raspberry Pi, and we are joining by Mr. Harold Pulcher.
Okay, I can certainly do that. Um, as far as the journey goes, I started. I've always been interested in technology. I get that mostly from my dad, who was a maintenance person at a manufacturer of some of the largest earth movers on the planet. And he had to go fix all kinds of stuff. And I was right there with him fixing. I never saw a thing he couldn't fix, whether it's electronics or plumbing or heaters or building woodworking, building stuff for mom, that sort of stuff. I he had a drill in my hand when I was, I don't know, yay tall or so, doing stuff, cutting things, building things, and that's kind of just continued on, and what I'm doing today. I've kind of taken that master of none technology, master of none philosophy as I go forward in my life. I collect skills. Some of my skills have led me to here, being a Microsoft MVP, um, dealing a lot of times in software. So on a daily basis, I I sling code everywhere from all the way down to the bottom database layer, persistence layer, all the way through up to the front end layer. In fact, Friday I was scaffolding out some new sections in our Angular app which we're using ASP.NET Core behind that. Uh, on the weekends and on the evenings, which I'll show a link here in a minute when I get in the formal presentation, where you can go uh, follow me on Twitch. I like to make things, build things, pretty much putting the software that I do using the software principles I have and use on a daily basis in conjunction with software and hardware, and then making the hardware smarter. And and I really enjoy doing that. Sometimes I have to bang my head in the wall, but I continue to learn. I believe that I can learn something new every day. I believe that also the day I die is probably the day I get up in the morning and decide I'm just not going to learn anything today. I hopefully live a very long time and learn lots of stuff. Um, let's see what else. Yeah, my dad passed away a little over 20 years ago. But I do believe with the 3D printing and all the other stuff I'm in the middle of, he'd probably be standing here beside me, not doing the presentation necessarily, but right in all the technology and all the stuff we got going on. It's pretty funny. I can go in stores today and they'll say, "Oh, are you Butch?" I'm like, "No, that's my dad," and that kind of stuff. So my dad had a great influence upon me. Then as far as getting to where I am here, after I got out of college in computer science engineering, I started my own business. I was self-employed. I worked for Bell Northern Research, or now it's called Nortel, and I learned a lot of networking there. I was one of the Unix specialists there, and after that, I got into this thing called Convex. We built supercomputers, and that was a fantastic learning experience. Not only did I get back in source code, but I could write kernel things, and the people writing all of this amazing software were just down the hall, and I was responsible for people calling me from all over the world with their multi-million-dollar machines, going, "Hey, why does this work?" And the answer of, well, it just doesn't. It's not going to fly when they're paying that amount of money for machines. And so I had access to go learn from these really smart individuals about the internal guts of how a lot of things work. After that, I got into the .NET world. .NET, I'm not .NET world, the network internet world, and I went through all that .bomb stuff, the .com. I almost had a bazillion dollars in my pocket, but then it all went away real fast. And learned helped start up Vario. You may know these folks because they're still around all over the, at least in the U.S. anyways. Or NTT America is what they eventually got called because they were bought by those guys. And I was running the network operations center, all of that, managing it, and got to know a lot of really smart people in the industry, and learned a lot about it's funny. I learned a lot of things, and maybe the most important thing I learned is I am no manager. I try to. I'm not so sure in the technical. When the technical and the human world, managing technology is easy, is dead simple, as complicated as it can be, as opposed to managing human beings, which I'm still fighting with how to do that. Um, and then from then I became self-employed, and I got a whole new set of learnings going on there. I learned how far I can go, how far I want to go, and also learned that I was not a very good salesperson. And I relied on a lot of individuals to help me through, and I thank them very much for that. They're some of my best friends. In fact, one of them was best man at my wedding. Um, and then when all that started to go down somewhere around the end of 2010, 2009, 2010, I went and got a real job. And it was my first software only job, even though I'd been doing a lot of software along the way for individual projects. And I learned a few things there as well. And I thank Leads Online for giving me the opportunity to grow. And after that, I went to a place called Improving, which is where I'm working now. And I learn stuff every day there. And it's the only company I've ever been in that expect 100% of you every day and help you be better the next day. If you want to be, you don't have to be. But if you want to be, there's tons of people around you to help you know more than you did the day before and explain things, because there's lots of smart people there. People think I'm one of the smart ones, and I actually am. One of the things I have yet to get out of my personality is self-deprecating humor. I make a lot of fun out of myself. When I say I'm not a smart person, that's me sort of lying and me poking fun at myself. And I know I'm pretty smart. I know I'm pretty smart. However, the people that I'm looking up to, the people I aspire to, don't know as much in certain areas as they do, and that's where I'm comparing. That's where that comparison comes through. I was told that no, Harold, you're smart, because I was talking to a guy, and he's one of the most amazing people I've ever met. And he goes, yeah, but Harold, you think I'm, I said, man, I don't know how I can even keep up with you. He goes, Harold, you can put Windows 10 on a toaster. I can't do that. And I said, well, yeah, I guess you're right. We all have our strengths and weaknesses. So I fight, and one of my things is I fight imposter syndrome almost every day. And sometimes every hour of every day. And that's me being hard on myself, even though that I know I'm good enough. So I don't know exactly where this story is going to end. Maybe it ends because where we're starting here in this presentation that we're going, it's not ending here, but it catch you up to its current progress. At the moment, I'm on a team of fantastic individuals, and we're on a project trying to help doctors and nurses go from places where they're not needed to where they are needed with the COVID stuff that's going on. Here in the U.S., we do have some control over it. I don't know how much, but we're trying to help it where if a doctor has spare time in one location, in one state, they're licensed in, they can get easily licensed in another state or get a waiver so they don't have to get a license in another state and help them remotely. That sort of thing. That's my current project, and I think we're doing some good there. It feels good to on this project we're actually helping other people or attempting to help other people. How much help we're going to be, I don't know. We're getting there. And I don't know if I can say any more. I'm at So we got any question? I'm hearing some things, some clicks going on, but I don't hear any words. So almost like somebody's hitting the space bar is what I'm hearing. I can see you.
Great,
Yeah, I can see
uh,
you moving a
can you
bit
hear
there.
me now?
Yes, I can hear you now.
Yeah, there has been a lot of internet breakages, but your journey is really beautiful. It's very encouraging that you're a crafter from your right from very start, and then you turn that crafting into technology, and then you are doing amazing things with that. So it's really amazing, and sharing knowledge is also a best part to add your contribution to the community, and prepare next generation that how they can also get creative with what they have, because I know uh, 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 definitely at your time there is definitely very less opportunity, especially in technology. Now the technology has also evolved a lot, and there are a lot of things in technology that are very ease out the development, especially the development phase, because with my generation, when I starting my programming, uh, you know uh, we are at the start of having the libraries and all those stuff. Current generation have a very advantage in that area, that they've been given a lot of tools and a lot of features that really ease out their development, and they can have more focus on the innovation and the creativity of the technology.
Yeah, I do a thing. This last year it was messed up, but for the last several years, where physically live is almost a technology desert, meaning there's no tech companies here. It's in the traditionally lower, less affluent, although that's changing, section of Dallas Fort Worth, and I get invited to these elementary schools for a career day. And the first time I went, I didn't even know what I was doing. I saw all these people bringing all these things. I brought a couple of my toys here, my 3D printing thing that I do. I brought some of those things, showed it off, and blinked some light. I looked back at the back of their room, and these uh, what I thought was technology desert have a whole mobile platform of probably 50 um, Surface tablets that they use and they work on every day. And I'm like, when I was a kid and growing up, and if I got something with a battery and a light bulb, that was an amazing thing to me. And these kids have all this opportunity that they can go do crazy. And so what I've done the last couple of times, and what I'm going to do again. I've got them all prepped over here. The last couple of times I've had them make things or put things together. So I don't know if you know what squishy circuits is, but if you take Play-Doh, and I hope that translates well, Play-Doh, you pull it out of a can and you make stuff out of it, right? That's electrically conductive all by itself. So I put together with some support of my company and some other folks a bunch of little Play-Doh, um, and got a bunch of LEDs, and I got a bunch of 9-volt batteries, and we made all these kids. About turns out to almost 100 of them was made them electrical engineers for the day. They're all second, third, and fourth graders. And if you take Play-Doh, it's got a little resistance to it. You can put an LED in it, and then put a 9-volt battery across the Play-Doh. Your LED will light up. And I had them I made worms, so that because I am really uncreative when it comes to this. And not only did they take this, somebody made them a little computer, and also gave them a playing card, which you say, what do you need a playing card for? It's Play-Doh's easy to cut, and a playing card's a nice way to cut nice sections. This one young lady got up and made not only a little computer monitor, but made a little bit of a keyboard and was making slices and cuts and stuff so you could see like keys in it. And it was fantastic. And she had a light going between it. One of them figured out how to make a switch, meaning she had everything plugged in and nothing turned on. And when she moved one piece of Play-Doh to another, it turned the light on and off. She could move it back and forth. She figured it out all by herself. I thought that was fantastic. And not that the other thing that made me really, there's more things that made me really happy. One, the kids got to choose what place they went to. So I was going up against firemen, police, some architectural folks, coaches, those sorts of things that they have traditionally seen all the time. And a couple of kids remembered me and like, oh, that guy's cool. Go in his class. And I had 20, 25 people in 4 different classes, and they each got to take their own little Play-Doh kit home to, I guess, annoy their parents maybe. But that was one thing that made me happy, that they chose to come see me on this. And the other thing was the girls were outnumbering the boys and wanting to come in here and learn that stuff. And traditionally, this technology stuff has been a male-dominated field. And there's nothing, absolutely nothing about the width of my shoulders, or, well, I'm a little heavier now than I was, the center of gravity in my physique that makes me any better or any worse than a female that's a little bit different to do this kind of work and to excel at this kind of work. And I was really happy to see that. Really happy to see
I think, yeah, I totally agree. I think technology is actually the domain that give you a lot of versatility. You have, advantage of, learning other domains as well. Like, you're not just inclined to a technology itself, but you can, learn about the healthcare section. You can learn about, other like financial domains, and you can, all like other sort of domains also. It gives you knowledge of those domain as well. And technology, is a domain that is, kind of very innovative and intuitive, and people who really want to do something, and they really give them kind of a motivation, especially people who are a bit of an introvert, and they are very shy with the people. They can easily utilize technology, and bring out their creativity as well, and don't feel left aside. So it really add a lot of value into a lot of people and their lives. So yeah.
Yeah, I think that I am so on with it. I will tell you, even going through college, that's for instance, when I was going through university, I think is how most people say that. Going through university, um, it was male dominated, but the females that were in there, the few that there were, they dominated us. They were fantastic. I had to work to keep up with them, and in fact, some of them I couldn't even keep up with, which at the time I didn't realize how awesome that was. But now that I reflect back on it, I certainly respect that, and that kind of thing. There should be more. That's all there is to it. There should be more.
Yeah, that's what technology is all about. So let's, start with your session, Harold, that you're going to, tell us about
Sure.
what it's all about. And, now, I'm just giving the handler completely to you, so you can, begin your session.
Okay. I've got OBS, and I'm going to switch over to my laptop that I've got plugged in and going. That has my presentation going on. If questions, we'll talk about that. So, if you'll notice at the bottom of the screen, I've got the translation going on. Not translation, but the transcription going on. So sometimes I speak a lot of East Texican, and it doesn't translate so well. So, yeah, so speak up, yell up, that sort of stuff. See what's going on there. All right. And I do have the comments up if those comments work. So if you want to type things in there and that kind of stuff, that's great too. But I have no idea if Asma is enabled. All right. So this is a talk I've given in Improving, and I'm a senior consultant there and a Microsoft MVP. Of course, you already know that. We do this every Friday. They're free. It might be a kind of a late evening for, well, it's not, it's a little earlier than this, and then we started here on Fridays. If you want to go over and register virtual events, we have talks about all kinds of stuff. They're absolutely free. Come see us. Talks on Agile, .NET, architecture, all of those sort of things. We got a whole plethora of things out there. And there's a bit.ly link down there if you want to see, go to our YouTube page to see all the stuff we have now too. Okay, enough of that. So here's what we're here for today. If you would like to take a picture of this, screenshot, wherever you want, these are all of my ways you can get a hold of me right now. You got my name, you got my Twitter account, you have my email going across. Then I've got a YouTube up there that I update on occasion, not a lot. Then there's my Twitch handle, or my Twitch address, that I stream Monday, Wednesdays, and Fridays at 8 to 10 Central Time. And you'll see, from my garage is what we're sitting in right now. And I've got, there's a bit.ly link there to this slide deck and a little bit of the example. I think it's probably just a slide deck because we, there's a little bit of examples up there, the push links up there. It already exists right now on GitHub. So if you want to go look, follow along, get ahead of me, get about the guy, I don't need to see any more, that's fine. But if you hang out, please do hang out. I will show you this at the end if anybody wants it. And as far as questions, comments, and that kind of stuff, go ahead and ask the question whenever. If I can determine the question is relevant to what we're talking about, we'll go ahead and answer it. If not, we'll try to save that to the end, and we'll have a whole bunch of question and answer stuff. And I'll be happy to answer any question you have about anything that you've seen here today, or even potentially about other things, because I usually get lots of questions about other things once I start giving tours and showing what I've got going on in my garage. All right, so here we go. I'm going to start with the agenda. We're going to go a little bit of overview, which may be familiar to most of you, but I don't know. It's kind of hard to tell. Requirements for doing this. I'm going to walk through some steps to set it up. We'll do a little bit of a hello world. Then we'll make it, in the .NET world, you know what a hello world is, right? Then we'll make it a little better. I think it'll make it a lot better. Well, first I'll show you off my talking head. We will not go into that too much because I think that's another talk brewing, by the way. But I'll show you off and see how you can integrate some of this stuff with it. And then my ask for you after at the end of this presentation sometime in the future, go give it a try, and whatever questions you have, go give it a try and whatever questions you have. All right, so let's do this. Let's put me in the picture here so you can see. So here's the overview. Right, .NET now is a unified platform. It doesn't matter. It's one application, one developer, one process, one host, whatever. You can use this on any major service you have these days, whether it's mobile or gaming, IoT, which is near and dear to my heart, and AI, which again, something I like to play in and do. And we have plenty of tools. Visual Studio, the Cadillac of all this, right? And Visual Studio Code for Mac and PC and Linux, And of course, if you just want to play on command lines, you can do all of that too. We have a .NET schedule, what's going out, which if you caught any of build this last week, .NET 6 has been slated for November release, has been slated for November release for a long time, but I believe they gave us a date and build on that, which is pretty ambitious because most of the time they don't give us dates this far out. And if you'll look at we're in .NET 5 right now. That came out in November of 2020, not too long ago. And .NET 6 is going to hit in November 2021, and that's going to be LTS. And what does LTS mean? Long-term support. So in Microsoft world, long-term support usually means 10 years. So if you adopt .NET 6 now, whatever you're going to do for the next 10 years, you'll be supported with updates and all that sort of thing. One good thing, so a lot of good things Microsoft's doing these days, and I find that excellent. So we need some requirements for this. There's some have-to-haves and nice-to-haves. On the have-to-have category, you need a supported OS. In this case, for the demonstrations today, we'll be using Ubuntu 20.04. So we're using Linux. It's not a Windows, it's not a Microsoft operating system. It's Linux. You use it wherever, right? You'll need, in this, I'm expecting .NET 5 right now, but I think we'll transition over the next month and a half, maybe two, to .NET 6, because that's the new hotness. I really want to let it get out of preview before I start doing talks on it. You'll need a Raspberry Pi. I say Raspberry Pi 4. Raspberry Pi 3s will work. The Raspberry Pi 2s currently have a bug which stops them from working. There was an issue I was following. I don't know if it got resolved or not. Today, you'll be seeing a Raspberry Pi 4 with 4 gigs of memory as our main demonstration platform. And when we get over to Mr. Big Head, that's what the streamers call it. It's a Raspberry Pi 3 on it, but so it works on both. Your favorite Linux editor, I really like VI. Kids today call that VIM. VI improved, I think is what it stands for. And I know there's other like Pico, Nano, and a few others that are out there. Back in my day, it was what did you code in VI or Linux? VI or Emacs? And that was a big religious sort of war going on there. I don't know anybody today that uses Emacs on a daily basis. Of course, I don't know very people that use VI or VIM either, but I know a couple more of that. Maybe VI1. I don't know about that. You will need a network connection because you're going to have to download stuff, and you're going to have to, and you want to be able. In this case, my Pi this time is headless, meaning I do not have a keyboard, I do not have a mouse, I do not have a display on it because I don't need it for what we're doing. You also need root on your Linux OS. And when I say Linux OS, I know today's demonstration is on a Raspberry Pi, and so everybody has root on that. This doesn't have to be on a Pi. This can be on any Linux operating system that's supported. I have a page on the very end. It's got a bunch of them supported, but usually that clouds the issue. So if you really want to see it, have a comment, and I'll show it to you. But you need root access to that, and I'll explain why as we go along. Nice to have is Visual Studio Code, which is what we're using today exclusively to do all the work we do. Visual Studio Community at the very least. You don't need Enterprise or Pro or any of that kind of junk. Just Community works really well. A couple of extensions you're going to need to get to use Visual Studio Code, and that's the remote development extension. We'll go over where that is and install it. You need to have access to an SSH client. Many are not aware, because I wasn't aware when I started this process, that SSH is built into Windows 10. When you install Windows 10, you get an SSH command. It's OpenSSH. You get the whole suite, not just SSH, but SCP, and a few other of those S commands for transferring. Excuse me. Okay. Windows Terminal. If you're still using just cmd.exe, please stop, unless there's really a good reason to use it. Windows Terminal is a much better experience, and you get your scrollability, Windows section panes, tabs, all that stuff. I've got a friend of mine still uses a CMD. I was chastising him yesterday, and the reason he's still doing that is because he's using another tool called ConEmu, which gives you a lot of the stuff. It's still not Windows Terminal, but it gives you a lot of the stuff that a Windows Terminal will give you, and it's been around a long time, and it's very popular, and it's a good tool. Then you need a .NET 5 SA for your OS, your Windows 10. You don't necessarily need it for on the, because you already got it going to have it on the Pi. I will be developing software on writing code, that sort of thing, on my Windows machine and shipping it over and running it on a Pi and debugging it on a Pi from my Windows machine. So you'll need an SDK to help with all that. All right. Here's the setup. First of all, you'll grab all the Microsoft dependencies. Now this is on the Pi. There's a lot of packages that the .NET Core is going to, or .NET is going to require. That's a list of them. Again, I don't expect you to write that down. That's why I made this available in the GitHub already and put it on there. I will tell you, I got a lot of this going through the web, and this is a collation of some of that. Scott Hanselman has a good write-up on this, and there's a few other people that have a good write-up on this on how to go about doing this. It will lead you to the Microsoft documentation that will point you right to that line. Or you can just get my PowerPoint slide and cut and paste that. If you don't know what a wget is, that's a way to download things from the web, through the web. You can do it. I don't know how familiar you are with Linux. And so if you got questions on that, shout them out, ask them away. You can. All right, now you're going to download a .NET package. At the time I created this image, it was .NET 5.0.102. I suspect there's been a couple of that. Wow, what's the matter? Excuse me. I suspect that 102 is somewhat higher now. But if you'll go to that HTTPS location right there, you'll find all the list of packages. Here's what you're gonna find about doing this. See, you have the installers and the binaries. Hold on. It's gotten into me. Let's see if it's not too crazy here. All right, I'm sorry about that. What I was saying was, you have the application there for the installer, and then you have the binary. In the case of what we're doing now, since it's on a Raspberry Pi and it's on an ARM64, you're going to want to download the binaries. Wow. For Linux, because that current installer doesn't work. Well, it didn't work at the time I made this. It may work now. I have not gone back and checked it out. Right? That'll get you down a file, and we'll show you what to do with that file. This gets it down to your home directory. And then that one command will make a directory called .NET in your home directory, unbundle that entire file you just downloaded, and into that .NET directory. That's all there is to installing .NET, is just unbundling the tar file. You need to set up some environment variables, like I said, with the .NET root, and add the .NET to your path so that the .NET command itself works. But if you're going to do this for an entire system, let's say this is doing it for you. I want to play it on in my own space or whatever. But if you want to do it for an entire system, like every user that's on your Linux box, or in this case, the Raspberry Pi, if you have multiple users, or you have multiple users for different functions and you still want them to use this, you need to put that, Don't set those environment variables, and the system will want to install it at the following locations there, right down there at the asterisks. Um, usershare.net. That makes it available. You'll need root to do that, but that makes it available for everybody on the system. Right? Okay. And I know that was great, right? You're like, oh, thanks for those commands that I can't run, and thanks for all the other stuff. Could it be this easy? Yeah, it can be. So let's dump out of here. Oh, look at all that stuff. Hey, we're gonna have stuff with Asma. It's awesome. That's my Visual Studio. I have my Windows terminal, and this is me prepping to make sure things work. So I just want to show you that I am on a Linux box running, and I've just made it mad. No, I didn't make it mad. Hold on. Make sure everybody can see that, because I scroll it up a little bit. I got a little more font on it. I'll do this. That's me playing there. I'm gonna exit out of it because I want somebody to say, "Whoa, how did that happen?" And that is the top, so we can see everything that's running on there. Although I don't have a head on it, the GNOME is still running on the thing. I haven't disabled it. Okay, you see what I've got here? A total of almost 4 gigs of memory, and there's a bunch of it free. People are using it. They know what they're doing. Whatever. I'm caching and buffering a lot of it, right? So I take here. I'm on the Windows. Listen to what I'm talking. I've got WSL2 on here, so I can type ls and grep it. It knows what that is. And, well, that's PowerShell. If I was in a command line window, I could do that. So, first thing I'm going to want to do is get on the Pi. And in my case, since I'm not going to type all that out, SSH is already built in. Oh, let me disable that. That's my Discord channel. That anybody on here would like it, I can give you a link, and you're more than welcome to join. But so SSH, I'm going to get onto the Pi so we can do stuff. And as you go through there, you may recognize something here. What did I not do? I didn't enter a username. I didn't enter a password. I mean, you can say the username well, you did enter a username right there. And yes, I did. But I didn't give it a password. It just let me in. You know. Still secure, though. I can show you why in a minute. But we'll talk about that. So I've got some examples. If I could talk, if I could type. That push blank is coming. I just left it in there for safety reasons. So if you've not played around with the .NET command before, or not played much around it, there's a lot of things you can do with it. A -H will give you most of it. Info, like right. My OS is Ubuntu 2004 Linux. ID where my base pass is, so I installed this. So every user on the Pi, however many that is, it's just me really, put it in there. It's just there. Where my SDKs are installed, and what runtimes are installed. The runtimes are the important one. The runtime, there's a few ways you can compile your application. You can compile it to expect the runtime to be there, to not expect the runtime to be there. And if you do it, if you tell it to say expect the runtime to be there, your applications become much, much smaller, because depending upon whatever the OS you're going to have that runtime for you. If you don't expect it to be there, because you don't know who's going to install this somewhere, it becomes a self-contained entity where you can compile it, drop this on the system that doesn't even have .NET on it, and it will work, right? And how to go download and that kind of stuff. So what we're going to be doing today is we're going to be making a new, I'm on the Linux box, on my Pi, and we're going to say .NET new, and I'm going to give it a list. These are all the various bits and pieces that I can do right now on this machine. If I need a better, somebody in a previous presentation goes, well, do Blazor app work? Yes, especially WebAssembly, because the WebAssembly is actually working somewhere else, working in the browser, right? And the server works because it's an ASP.NET Core. What we need, I'm not set up to do this today, but if you got a web server on a box, you can on a Linux box, WebAssembly will work for you. It's a static. It literally is a static file that goes up there and works. But yes, it works. So console apps, this kind of thing. The thing that would that we're going to be working on today is going to be a console. Also, the Talking Heads is a worker service, and you can see the languages that are currently supported. And we're being on C# today. Anybody do BB anymore? I know people do. I know people who do it, but I don't run into them. I'm running into them less and less. That's it. Yeah, that's the only SDKs I have loaded. If you had more than one SDK loaded, it would show it there. There's a .NET. Let's look at the list again. See where it says .NET build? It's just like anything else. It has a bunch of commands on this command going down, and you can tell it what version, the verbosity of when it builds. You can tell it what runtime to use right here. So you can have all those runtimes side by side and build it for whatever runtime you like. Try it out. Does it work in 3.1? Does it work in 5? Does it work in 5. Whatever? Does it work in 6? Using your same source code. I think that's really cool, especially when you're trying to migrate and see what the difference are. Okay, but today we're not doing that. We're just going to do a hello world, right? .NET new and console apps the way to go. I'm going to say hello to Asma, and that's going to create me a folder, a program, projects, a solution, project file, and a package. So let's go see what it does. See, now I've got one of those. I've got a program CS, the project, and an object directory for putting things into that we're going to need. You're like, well, what do those things look like? By the way, I'm specifically being old school with the command line here to show you, yes, you can do all of this stuff without any fancy IDE whatsoever. So if we want to look at this CS project file, it's the same project file you're going to see on your Windows box or any place else. The object thing is just a directory, and if we more on the program, that's the most amazing program I've written, right? And in fact, this is using not the latest C#. The latest C# turns that literally into one line of code to make that happen. Yeah, that's pretty cool. But this I don't have that compiler in here, I don't believe. So I didn't tell it to do that. So if we run this thing, it's going to go around, compile those sorts of things, download some stuff. We get the hello world. And so Let's go change it to you make sure that make sure I'm not lying. We just changed that, right? I'll run it again, and then we're going to show you what that all built for, so you get an idea of the directory structure that's going on. Hello, Asma. So now what do we have in there? Let's go look at the directory again. Oh, we got a new thing. It's got a bin. We've never seen a bin directory before, have we? And inside of bin, there's a debug. Never seen that before. .NET 5.0. Oh, we got some more stuff here. PDB file for debugging, right? You got some JSON for the runtime configs on it. You got some dependencies for the JSON. Then the interesting thing to look at, you have an executable and you have a DLL. So if we run the executable, it just runs. You notice how fast that was as opposed to the other two times? It didn't have to go check whether it needed to build or something. It just ran the executable. All that really is doing is bundling, spooling up. You see the difference between the Hello Asma and the DLL? You know, the DLL, that's what controls the words hello, comma, asthma, right, and all that programming stuff. See the difference in size? If I were to compile this and tell it not, or to expect a framework, that's what it does by default. Or not expect a framework, that may be substantially larger. Because all this is doing is setting it up so that we can import that DLL and then execute that DLL in the middle of it. So cool, huh? I didn't think you'd be impressed. So, so let's see. Let's see here if we can make it better. Okay, yeah, it can't be that easy, but you know, that's okay. So let's make it better. You're going to want to install Visual Studio Code. And then you're going to want to install the remote development extension. There's a link to it right there, but if you go install extensions inside of Visual Studio Code, it's a extension off of that. But you can go do that inside of Visual Studio Code or not. You're going to want the C# extension. Pretty straightforward. And now this is where the fun part comes in. You remember when I logged in, I did not have to use a password. This is where we're going to be talking about why how to get to set that up, how to start to set it up. I don't have complete instructions here. I'm not going to run you through all that. But and we'll talk a little bit about some of the security concerns and how that really makes me queasy. But it's relatively secure as long as you don't share these things called ISA keys. So SSH keygen is on your Windows box right now. And OpenSSH is on Windows 10 by default. You want an RSA key, and you want to make it a 4096-bit key, and you need to make two of them. One of them for you to log in as the user, Ubuntu or normal user, and the other one to allow root to log in. And yeah, that's a little scary because we're going to allow root a passwordless login, not unsecure login, because you have to have a key, public-private key to do it. But if somebody else gets that key, then they don't care who you are. I've got a key, I'll let you in, right? But we're in a pretty safe space with the Raspberry Pi. We're pretty well isolated. In other situations, you may want to rethink how you want to do this. Certainly in a public production environment, this would be a very dangerous thing to do. But luckily, most of the time, when we're doing development, we want to make it easier for the devs. Get the pub files over there with that SCP command. Again, it's on your Windows box right now. A lot of times people will get Putty, install it, do that. And Putty's a great tool. Used it for years, but now I just don't have to go get that. It's in my Windows. Then you need to make sure you can do SSH access on the remote Pi. Here's an example of one set of steps to go do it. I don't know the folks. I have no idea who they are. I found them on the web. It seemed to be a decent write up, and so I'm putting them in my talk so that I don't have to include all that noise in my talk. It's an exercise for a user, definitely. Okay, now the other thing we need to do is we need to give root a logon password on the Pi system. Root doesn't have a password, so no one can ever log in as root. But in this case, we're going to need to. So root needs a password to light up a few things. We're going to put the pub files in the right places. One of them is going to be in your own home.ssh directory. If you're not familiar with the Unix-based system, you have these dot files that are hidden. They can call them hidden files because in LS and most normal stuff doesn't show up on it. In Windows, they're hidden. You can hide them if you like. And there's two different places. The key is file name there is authorized _keys. That's where the SSH daemon will go look for you as a user and then look for that file authorized keys and see if your key that you have and the private key and the public key it has matches up and let you in. You tell the SSH daemon, hey, root can do these things by sending that permit root login. Yeah, I get a little squeamish. That's all right. It'll be fine. Say the file reboot. If you're Linux enabled, you can get in and just go ahead and restart the SSH daemon. But I find most people just want things to work and just hitting a reboot in a couple minutes you're done. All right, okay. Oh, look at there. Now what? Need to, and this is the next critical piece. Next critical piece. In order for us to do what we need to do, we've got Windows on a laptop, desktop, something. We've got a Raspberry Pi or a Linux box or something here. We need to be able to get access into the internal guts. Let me see here. Can AI models be deployed on a Raspberry Pi? Yes, that is a yes, by the way. If it's running in .NET, it can be there. I'm checking a second here. If it's running .NET and you put the AI models like AI on the edge, that sort of stuff, that's exactly how that stuff works, as my current understanding. I may get some more. I need to get some more in-depth understanding on that. But the overall answer is yes. I don't have the details, right? And so now, what you have to be able to do. You have your Windows or your laptop or whatever you got going over here that's your really nice development environment. You have the Raspberry Pi, which can be a nice environment too, but most people see that as a command line and they don't like to know how to hit the escape key to get out of VI and all those other sorts of things. At least coming from the Windows world anyways. So you're going to need a way to have something on the Windows or in the Raspberry Pi that the Windows things can communicate to and get access to the internal structure of what's going on for debugging and that kind of stuff. Hence, this is where you need to have root and have access to it. Right? So this command here gets you there, gets it installed. Okay, what we're seeing now, still need to set up a bunch of stuff, but that is the application and what we've put together. And if you look on the AI stuff, it's hard for me to tell. It's hard for me to tell, but we will. That's something I'm about to learn actually, because I've got another project over here that I want to put the AI models on, and it's Raspberry Pi as well. And I'm going to be doing these very things that I'm talking about on that to explore how much that pulls. Just so you know what we're looking at here. Yeah. I'm going to give you an up close and personal. Yeah, a little bit of up close and personal. So this right here is our demo everything that we're playing with today. I got a couple LEDs. I got a Raspberry Pi. The thing that's on is something called a donkey car, something I'm playing with, trying to do, and that mimics that circuit you saw right there. All right. So, being of all that, don't need that no more. Or not at the moment, anyways. So, let me get out of here. So, in case anybody's wondering, there's a .NET with a slice of pie. I got a little bit of an example there. Go look at that, and we're going to need a couple things. One of the things we're going to need is Visual Studio. Now, what I've done already, if you look, I have this open in my own local location. Can you see that? Okay. I'm having a little bit hard time to see it on the monitor. Let me zoom that up a little bit. Hopefully everybody can read that well. So I went and did a .NET New on a console application, and then I started making stuff. Started coding it up. It's a little more substantial, as you see, than the Hello World, but not so much so. And before we go too far into what this code looks like, I'd like to go through the code structure and show you. So if you will see this, we got a couple of things we don't know what those are. Those lost JSON, attached JSON. We'll go over those. We have this published bat thing. What the heck is that? Then we just got the program and the push blink that we've seen before. So it looks just like our Hello World program we just had. Not a big deal. Thank you. It looks like the program we just had with the Hello World. A little bit more lines of stuff, right? A couple of extra fold files, and we're going to go over what those files are. You believe it or not, you are using a launch JSON now. You just don't know it if you hit the F5 button on a .NET 5 and above application, or .NET Core above .NET 5, all the way up in that application. You're using launch.json, but you just don't see it a lot of times. So let's go look at this launch JSON. So I will tell you, when I started going through this, it took a long time for me to get through this because, just make you a launch.json file and, do some stuff. I'm like, how do you do some stuff? I don't know what do your stuff means. So it took a while to ferret through and figure out what's going on. And once I did, I made this, and this is one of the reasons this talk exists, is because I wanted to share this out with others. So this is not a complete compendium of what's in launch.json. Don't let me give you that impression. This is how this works, and I've expanded on the very basic stuff that I found to include these other stuff. So I got two of them here. This one right here is I really like that one. But this is what we're going to be using at the moment. Okay, I give it a name. Who cares what the name is? Make it whatever name you want. I give it a type, a request. I want to be a launch. And I got a pre-launch test. See that published there? That word publish suspiciously looks like this word publish over here in this other file. There's a kind of a reason for that, right? All right, and what programs I'm going to use in this case, because I've got my .NET in a couple different places on this box, I'm going to use it out of my home directory. I've got some args. When I go run this thing, that's the arg I'm going to use to run it. Argument I'm going to use it. See, in this case, I'm just running the .dll in the thing. I'm not running the .exe for various, if I say for various reasons. That's how I set this one up. It doesn't really matter which one you use. In this case, I want the debugger to eventually do what I want it to do, so I'm there. Where my working directory is on the Raspberry Pi. And if you remember back over here, that's exactly where we are. And that tilde means my home directory. Home Ubuntu example. Again, not knowing how familiar everybody is with Linux and how that stuff works. I'm not going to worry about stopping an entry. This stop an entry is actually kind of cool because you can tell it to stop at the entry of this DLL here. So then if you need to attach debuggers or do other things on it, you can tell it just to hold off and you can do that and then tell it to go. I'm going to use the internal console, which you'll see that come up in a second. This was fun, this pipe transport. So where's my water? I thought this was going to be so complicated, and I thought it was going to be crazy, and it wasn't. After I just took a moment and took a bite of it at a time. Pipe transport. This is how I get my Windows and my Visual Studio Code and the things it needs over the net to the Raspberry Pi. This is how that works. And this is me telling it how to go across the pipe. So it's going to encapsulate a request here, pop it over to TCP/IP, unencapsulate it over here, and do what it does. All right. You can use, because I'm using the internal SSH key, SSH, not key, wrong word, the internal SSH command, use that. You can use anything that will accept a pipe, a redirect pipe into it. If you can't do that, you can't use, there's certain applications that I've used in the past that I couldn't get to work. I'm not even going to go over that list. SSH on your Windows 10 box works. And then I need to give it some arguments. And you saw how I logged in before, right? This is all that it is. Same command, right? That's exactly what we just did. But in this case, if we're doing it in a programmatic fashion and we're popping bits across of it, it's all set to do this. I've given it my debugger path. You remember the debugger we loaded? It knows where it is, so it can fire that up. And that's the launching. That's the activity that we're going to have for the configure. That's one of the configurations we have to launch that particular command. You can have many of them, and you'll see I've got 2 of them in here. We'll work on that one in a second. A little different on that one, but we'll go over that in a second. So let's look at this published batch. So let me close this up. You know, I said this published, this pre-core thing, pre-launch task. So this, if you look in here, there's nothing in here that says all I'm going to do is connect up. It doesn't say anything about compiling. It doesn't say anything about moving stuff. It doesn't say any of that stuff that you know you're going to have to build this thing, right? That's why the published batch. Now this is rudimentary, and there is no doubt about it. There is nothing incredible about any of this. The couple things that you need to care about, that line right there. You don't need the /p if you don't care about it. Currently, I put it on there because I like to see a bunch of stuff come up. You need a .NET publish, so it's going to package and do whatever it takes to package and give you, for the Linux ARM processor, and give you output files, debug files to copy over. So yeah. So when I say anything to publish, it's going to launch in the current directory that you're in, .NET publish, just like you do .NET run. If you want to do a .NET publish out of this, you can do that and see what happens. But if it's going to build it if it needs it, and once it gets done building it, it will put things in the right place for rerunning, which in this case it's already going to do it when it comes up. So this is dead simple, but this is just a batch file to do whatever you need it to do to get it over there. And then the second line down here, the other line, this CD dot dot is me mucking around with not figuring out how I want to do things. You see, you're watching. I see a SSH. You see our SSH into it, right? And we've done before. You see how that works. This is why you want to set up password less authentication. You know, you're going to in this whole scheme of this thing, especially when I fire up Visual Studio Code, you may be entering that password a dozen times because of all the different services and all the different checks it has to make for it to work. Yes, I've done it by hand a bunch, and it got annoying really fast. I did that so you don't have to. I want to make sure I've got a directory, and then I use my scp command, and I did a -v in recursive. Let's just say I want to copy everything. If I was doing this for a major project that was a substantial size, I would do this a lot more sophisticated and target the stuff that I cared about looking over, not just grabbing everything out and junking it in. This is again, example presentation of how to get going. And then that's the whole command, SCP. I'm going to target this whole, come on. I'll target all of that on my Windows box. Log in as this user, remember? In this one line, you have to log in twice. And then we're going to go to our directory we care about, and it's going to drop all that stuff in there. Pretty straightforward. Okay, that is what the publish does for you. And let's go back over here. Let's go look at the tasks. So this task, there's your publish task. This is where that task gets called. I skipped a step. I apologize. I skipped a step. When I mentioned it over here with the launch.json publish, the pre-launch task, label, this is the publish, tops of shell, depends on a build. We're going to present it out, show some stuff, then call this at the very end on the Windows. You see the build .NET process, go. Ooh, I think I misspoke just slightly on that, and I apologize. But these tasks are what get you that. So this .NET publish, it basically calls that, calls the build, calls that, build, workspace. And this current working directory is the workspace folder that gets passed into. Easy peasy, like with this $ms compile. This is actually pretty cool. And I probably should implement this a little bit, but I didn't have a good example to work it up. I couldn't think of a good example that would work it up and all this. But what this is when you go build. No one ever makes a syntax error, right? No one ever has an error on one of their builds. The idea with this is you can write a command or write a series of things that will watch and look for several problems, warnings, errors, all that kind of stuff, and be able to short circuit this whole situation. Say, hey, stop the build, you got a problem, that kind of stuff. This is where you plug in for that. All right. So, okay, let's go back to the fun stuff. What we're going to do. Let's go back to this program. So what we're going to do with the program, because we are talking to hardware. The answer to that is yes and yes, Asma. Okay, the answer to that is yes and yes. It gets compiled, and you saw me with my .NET run, my Hello Asma. That's compiled completely on the Raspberry Pi and runs on the Raspberry Pi. In this case, what I'm showing you is it's being built on Windows, and because of that right there says, hey, I'm going to a Linux box and I want to be compiled so that it will run on a Linux box. Does that answer that question? And so we don't care where it gets compiled at, just where we're going to run it at. And so the .NET compiler is more than capable of compiling all that it needs to run, so it can execute on whichever architecture you want. So in fact, for instance, if you've got one application and there's a Windows version, and I don't know, I think in iOS, I don't know if you can do that with iOS, but there's a Windows version, there's a Linux version, and whatever other versions you want for various architectures, 32-bit, 64, all of that kind of stuff. You can spec that here, and in your publish, in your .NET publish, you get to tell it, I want to build it for all these various things. And if you saw in our directory here, hold on. See where it says .NET 5? You would get different directories there for each one of those things as you build. Yes, both ways can work. Yes, ma'am. In fact, you're about to see, you saw it running before with your Hello Asma, right? In this case, we're about to see it work where we build it local to Windows and ship it over. So here's how this thing is going to work when we ship this thing over. If you're not familiar, I'm saying them too much. So if you're not familiar with a GPIO, that stands for General Purpose IO, General Purpose Input Output. That's how, what we refer to in the IoT world of how the computer gets to interact with the outside world. There's analog and digital, and there's about 1 billion ways, and it's too long to go into right now. I say too long. It's a different talk, right? And that's how we actually interact with the outside world. And so we just put it in as GPIO and give us some drivers to talk to it. In this case, I've got a button pin, a constant blink pin, and a constant state and an activated blink pin. So if you look at like here, there's a pin over here attached to a button. This is the pin I'm going to care about whether it goes high or low, or in programmer speak, 0 or 1, or true and false. The constant blink pin is another pin. You'll see that that blinky light go on as we go forward, but that is a denotation that I am talking to GPIO pin 16. Yeah, I'm talking to GPIO pin 16. And so just to use it as I go down, using some better methodologies as I go. So this is my entire main. It's amazing, right? Absolutely amazing. I set up the GPIO and then run. Done. Okay. My time is over. So let's look at the setup GPIO real fast and see what we're going to do here. I set up some consoles so I can see the thing coming out. I make me a new GPIO controller, and I'm going to be using a Raspberry Pi 3 driver. Even though this is a 4, the 3 driver is they're pretty much the same as far as software is concerned. And then we're going to, much like you open a file when you're doing file reads and file writes, you're going to open a pin, and we're going to do an input on it versus an output. So I'll be looking for input, and if you know what input pull up means, fantastic. If you don't know what that means, the short answer is, if I have a pin out there and it's not connected to anything, I don't know if it's a 1 or a 0. But with this pull up here, I can guarantee that I get a 1 if nothing's connected to it, and then I have to attach it to ground or pull it down to ground, is how most of the electrical engineering people talk about it, to get my 0. So this guarantees that I will get a 1 out of this if nothing's connected to it, which you don't know if it's connected or not. We can go look, inspect, and see, but the computer doesn't know. And then I set a couple of output pins so I can blink some LEDs. During the standard state stuff, which this is kind of irritating me a little bit, I'm having to do some polling in the UWP program. In the UWP version of this, it was really cool. I could set up a delegate and I could watch an event happen. The current instantation of the .NET GPIO does not allow us to do that. I hope it's coming. I'll have to go ping somebody about that. I might know a couple people ping. But I read the button pin. I decide whether it's in this case, a 1 or a 0, or high or low is what we're going to call it. And if it's low, I do one thing. If it's high, I do another thing. In my constant state, I just want the pin to flip-flop back and forth. Sleep 100 milliseconds and do it all over again. That's all we're doing. That's all this is doing. So saying all of that, why don't we see if it runs? So in order to do that here, just a couple of things. Notice I have a remote run debug. Look at this. Those are the two names in my launch settings JSON. And I want to launch it up. And I'm going to hit the go button. And I'm going to make this a little bigger. You see I'm running the publish.bat. It's going. It's flying around. And this is what you get when you get verbose. I like to see this stuff go. I get nervous a lot of times when it's just sitting there and the cursor is blinking and I don't see anything that's happening. And this is it transferring all that it cares about, all that it knows about. See, with the core live DLL, you know, none of that's in our application. That's all coming from the framework. So by telling it to only expect the framework to be there, all of this would go away. Yeah, it'll get done there in a second. This is the longest one of these as it goes. We just did a compile. And oh, let's go see what's taking so long. If you're looking at resources, currently this is called top. And we're looking at CPU seconds. Yeah, load average, running, sleeping, stop, zombie. Currently not a whole lot of anything, and oh no. We got an IO exception. That's sad. That's really, really sad. Let me close this up so we can read. Just trying to run it. And we got an IO exception. I wanted to show you this. I knew it was coming. It was kind of a long way to get there, but I knew it was coming. But I wanted to show you this because you're going to run into this too when you try this. If you look where it says system IO exception occurred in device GPIO DLL, error 13 initializing GPIO driver. And they give you a line. See? Line, just like you do in Visual Studio. Absolutely like it. And you're like, well, what's going on there? I can tell you exactly what's going on. Remember I said this way back in a bit that you need to be able to log in root without password. All of this stuff that just happened, you notice I didn't put a single password in. I probably would have had to put a password, I don't know, a little bit, a few times at the very least. When I do it again in a minute, we'll have to put in some more. But because I've got that secure link with my pub files, my RSA keys, I don't have to do that because I've established that trust already. What's going on here is because this is reaching down from user application space all the way down to through the kernel to a piece of hardware on the device. It needs to have root access to get there. Because most of the time you don't want to let users in general talk to your hardware directly because bad things can happen. So all these people break into lots of stuff. That's one of the vectors. Anyway, so how do we get around that? There's a couple of ways. First of all, you got these nice little icons up here. I'm going to stop it all. Say no can't haves. And then we're going to go back over to the Raspberry Pi. You may notice we have some new files up there. See the May 29, the program C. Copied all that over. We're going to go in that bin. And literally when I said it copied, notice I got my own published not bad and all that kind of stuff here that, I don't need over here. But again, I did a naive implementation in .NET 5. And we got a bunch of this stuff. See how we did more when we copied over here? Because it didn't know where it's going to have a framework there or not. And it copied over more of it. What we needed. We got DLLs and we've got EXEs, we got PDBs, we got all that stuff. So I get the same response if I do one of these. Same response here. Because I need to be root. So the command to do that on most Linux is, it didn't always used to be here, but sudo's been there since su, super user do. And you give it command, let it run. Now it can have access to all of the resources it needs and how it works, and so it can do its job. Saying all that, when that fires up, give it a little bit. Okay, so we have indications, and you're like, well, I can push a button. Button press, as I hold it down, it'll continue to go up. You're like, I don't believe it. That's all right. You don't have to believe it. Show you. If I can get a better focus, you'll see the constant, the ring light going up and down. You'll see the red light there. You'll see the one button that I have. And if I push the button, light comes on. Absolutely. That's exactly what it was. The user did not have permissions to be able to access the resources it needed to get down to the GPIO, right? Absolutely. That's what that means. So that's all well and good, right? You got a blinky light there. You got a deal going on. Okay, cool. You're like, oh, that's good. Let me leave the blinky light going on there, and let's move things around just a little bit. I'm going to leave that running because I honestly believe that this is how a lot of this work will be done currently. And that's what I'm planning on doing, anyways. I'll be a little smarter with my publishing and moving things over in the future. Remember, that was one task. We had this launch task. We had this other thing called core attach. If I run that, it's going to go into the launch settings. It's going to read that whole different file, whole different set of things, which is up here. And in this case, the only really major change is if you look at our pipe args, we know what that, we don't know what that is, but we know what this is, right? We know what this is. We don't know is what are these two things. That -I, literally if I type that on a command line, it'd be SSH-I space -I space that bit of noise space that bit of noise on there. So the I says use a different identifier file. So now I'm going to go over, I'm going to pretend to be root. And right there, the user root. And since I've established a trust that from my Windows machine that I have now, I can go in as root and be trusted, then I can log in as root, right? Currently, yes, you can fix that runtime. You can fix that runtime, and it's called a sticky bit, and you'll change permissions on it. We'll try that in a second if you want to try it. Let me show this, all right, and we'll go in and try it to make sure, because it's been a while since I've done it, but we can certainly try it. But you're going to want to be root in this case, because you're going to need to run the debugger as root to be able to look at all the internals. So if I run this, I run this as a launch. Let me show you what happens. So, ooh, did it hit me that fast? I guess it did. So it's asking me what process do I want to attach to. It's already connected up, ready to go. Ask me what process I want to attach to, and we'll be talking to the push blink process. This is the thing that fired it up. See, sudo push blink, but this is the actual thing that we care about. And if I tell it to attach to that process, I get thread counts, watches, variables, right? My color changes here to say, hey, I'm debugging stuff. I'm in my programming file here, and it's all wonderful, well, and good. And if you're looking at the stuff, everything is still working as it's supposed to, right? So big deal. Why is that? Well, let me show you the big deal. If I want to know every time the button gets pressed, set a breakpoint, just like you do in Visual Studio. Set a breakpoint, and if you'll watch, breakpoint. Not only does it stop it, there you see our green light that's constantly flashing is now going away, because it's stopped. Everything is stopped. The code is stopped on the Pi, and I'm investigating it here on my Windows box. Not only do I get it stopped, I get, give me the status of this thing. It's hard to see that. Come on. The status is low. I get interpolation, so I can see what's going on here. Status is low. I get our done is false, and just like you would have in Visual Studio wherever you go. Our constant state should be true, so now we're going to turn that to high instead of low because it was low, and we swap it around here with that kind of thing. We're going to sleep. We're going to go. If we'd like to step once, we can step over. Step again. And in fact, if you'll watch the blinky light here, so now our light is on even though I'm not pushing the button anymore, because it still thinks I pressed the button, and that's what it remembers. And then in constant state, we're going to turn the green one high, and we do as I'm stepping through. So now I'm going to take that off again because that's showing the debugging, and I'm just going to let it run. So now it's running. So that was the idea I wanted to do. I wanted to run that thing and show you that you're debugging, you're stopping, you can do all of that from a very nice environment as opposed to trying to go through GDB or some other crazy thing. And I just saw from build, and I haven't had time to explore it, that you're able to get Linux crash dumps. Like when the thing just crashes and puts a core out, you're now able to get Linux crash dumps and bring them into Visual Studio and walk through them to find out what blew up on it. It's really cool. I need to get some more ideas. When I get some more, details on that, how that works and all that stuff, I think it's still in preview, but they announced it at build. I thought that was really, really cool. So let's go try to fix this thing, right? How would we do that? There's something called a sticky bit, right? If you look at the permissions, man, this used to be old hat, but it's been a really long time. So you see where it says RWX, RX, RX, it's owned by Ubuntu, that kind of stuff. So if I do one of these things and go sudo change on, we'll just make them all that. Change on root. Let's don't do all. Let's see how far we have to go. don't know why that's taking so long. Really? Okay. That's on my root. Now we can do a sudo change mod 4755. You know, I haven't done this in forever, so I can't even type. That's a great question, Asma. And when that comes back, you want to make sure it's changed. Something called a sticky bit. See, it says RWS now instead of before. There you go. And we're back to doing that, and so you can change that with the root as it goes. Would that be something you would want to put in your publish step, or that kind of thing to make that happen? Yeah. Yes, you certainly can fix that. Cool. So let me go back to this. All right. Let's talk about the talking head. I'm gonna move my robot out of the way, the donkey car out of the way. I'm gonna put the talking head front and center. We'll be showing him off and the like here in just one moment. Yeah, don't let the eyes get too creepy for you. So this is going to be a future talk about how this process works, which works a little bit different, and because this is working under System D, or like a daemon, or in our case in the Windows world, a Windows service. When this thing boots up, it boots up as a Windows service, knows how to play with being shut down, started up, and all those things, just like every other worker service that we've been using in the Windows world. It's controlled, exactly controlled by the system, does all the standard, interacts with the standard logging mechanisms, all those sorts of things. And I've got it set up with a button, just like the button I had before, to trigger noises. Like, for instance, this thing knows how to talk.
Without a doubt.
So I can hit the button, and it's based on an age-old, a really old thing where it had a big 8-ball, big ball about yay big, and then number 8 on top of it is black, because pool. And you ask a question, you shake it up, you turn it over, and there's a floaty thing that'll float to the top and give you an answer. Gives you answer, it's actually just a random thing that goes out. It's just fun. Because most of what Mr. Big Head here, that's what they call it, the twist train, most of what he says is kind of fun. Right? You got the match from Thingiverse, everything else I 3D printed. I 3D printed it all, but everything else I designed up and put together. And if you'd like to go see the talking head and how some of that works, some of those phrases you can say, you're more welcome to do this. Text to speech currently does not use cognitive services to do that, but that's my I wanted to make it run and then make it better. And one of my ideas on my Twitch stream is to put Twitch on here, a Twitch bot, to have him react to my messages. So you can say bang big head and give him a question, and he could respond either in Twitch or over vocally with a text to speech sort of thing. So let me give you a little tour of that, and I'm going to give you one of these. So do a close tour of Mr. Big Head here. The eyes are for a kit from Adafruit, and they can get kind of creepy. I've just got a standard button, joystick, and I can put the eyes in a mode where I can control the joystick and his blink by pressing on it. Back here is a pretty fancy board. You can see that? Yeah, pretty fancy board that's on top of a Pi. And it's the same Pi. It's doing all the same things we were just doing as far as accessing the GPIO and that sort of thing. There are a lot more cables because these eyes do take some signals. I've got a Wi-Fi going on there. I've got some speakers coming out, so that's why he's loud.
Have a nice day.
Yeah, have a nice day. And that's why he's loud. And so that's kind of a talk to come about, not necessarily the talking part of it, but how do you set up a worker process? And because I like to have a lot of fun doing things, I sometimes get up and make these things sort of fun. At least that's the idea, anyways. You know, like I can, yeah. How about I blink an LED every time this value goes high? You know, it doesn't, not that big a deal, and it's more fun for me. Hopefully, it's fun for others as well. So. And then this is my last slide. I do have one more if you care about versions, but they kind of make people's eyes get blurry most of the time. So I just moved it way to the end and only do it if people ask. And this is my ask. I asked you to go get .NET 5. You want to get .NET 6? Knock yourself out. And then write a program or two, and then get some Raspberry Pis and parts. If you want to contact me and for anything that you want, for if you, you know, hey, which Pi should I get, or what one of these things should I get? Any of those questions, all you got to do is reach out, right? Make something fun, and with both hardware and software because they play together. If you've never blinked an LED, the first time you were sitting on a web page and you click a button on the web page and your light turns on across the room, I think you're going to get hooked. I just really do, and that's not that, and that's stuff you can all build yourself. You don't need to go through Alexa and all these other kind of things going on. In fact, you could put the web page on the Pi if you wanted to, and make it all happen. It's really cool. You can follow me on Twitch and Twitter. That's probably one of the easiest ways, in really informal way to get a hold of me because I'm on that all the time. Send me some feedback if you like, or better yet, if you see something on one of these GitHub repos, give me a PR. Give me a PR on it. It's awesome. Let's talk about it, right? That's about all I have on this. And if you want some links, I got some of those too for you. Those are all the links. And Scott Hanselman helped a lot. Who hasn't he helped at some point in his career? And there's where to get to the Adafruit Eyes and the Talking Head, and where to download all the .NET stuff, and the manual install steps that I was just talking about. That's a docs at .NET, docs at Microsoft.com. It's a docs thing that you can go get and grab that and put it in there. It's pretty cool. In fact, that link may not be 100% correct. That dash looks a little bit funny. I'll have to go check on that. But I think that'll get you close. All right, that's about all I have. And thank you very much, Asma, for the nice compliment there.
I think it's a great session, Harold. Can you hear me clearly?
Yes, I can hear you.
Yeah.
Yes, I can hear you.
So I think it's a great session. There's a lot I actually learned from it, and I also get excited, especially looking the creepy talking head. That's actually give me a bit of a motivation that I should go about and try out some hardware as well, because I have been more into software side. I have never even touched the hardware side, so I learned a lot of things here. So I'm sure the audience also enjoy your session. So yeah, all right, Harold. It's really great to have you tonight with your amazing session. And if anyone else would like to contact Harold with whatever kind of IoT issue you are having with Raspberry Pi, you can reach out to him. His contractual information is also available in the screen, and he has also shared somewhere back in the video, which I will also be putting in detail. So I think that's about it. Thank you very much, Harold.
And thank you, Asma. Thank you, Asma. This was lots of fun.
Thank you very much. Take care, and Allah Hafiz.
Okay.